Good morning, students. Today we are going to discuss IIT-JEE NEET Foundation. The topic in the laws of motion, connecting bodies. See, we know laws of motion is a topic which comes under the dynamics. So, the dynamics is a branch of mechanics which deals with the bodies are at motion. Just a mind map. See, we are going to discuss. If you take here, there is the Newton's laws of motion and the causes of the motion. Newton's laws of motion and the causes of the motion. Newton's first law. The Newton's deals with inertia and referential frames. And Newton's second law. So the Newton's second law is a vital rule. See, very important law. And Newton's third law. Newton's first law, everybody it is explains about the referential frames. Referential frames are nothing but a coordinate system which is attached to the body, where the bodies are at rest or uniform motion. So the physical something, it's a coordinate system. So XY coordinate system. So that we will call referential frames. If it is connected to the bodies are at rest or uniform motion, then inertial frame of references. If it is connected to the accelerated bodies, that is non-inertial frame of reference. So inertia and the particular reference of frames which comes under the Newton's first law. So that is very important basic classification in the Newton's laws. The Newton's laws basic classification, the Newton's first law explains about the inertia, the inability of a property, the inability of an object which, so the object always resists the motion. Such property, the tendency of a body, so if it is at rest or if it is at motion, it trying to be the same position. So that property is called inertia. The inertia and the related things like reference frames, all this comes under the Newton's first law. This is the Newton's first law. See, Newton's second law, this is very important law. The Newton's second law is very important law which measures the force. See, the force equal to mass into acceleration and motion and all these things. In the Newton's laws, the cause of motion, see it describes the motion and the causes of the motion. See, describes the motion and causes of the motion, and the motion can be there. So that motion, so measures by the Newton's second law. The Newton's second law has lot of things like Newton's second law, see, connected to the mass. Newton's second law, it is frictional forces and causes of motion, description of the motion and limitations and standard problems in the Newton's second law. See, these are all the things which are connected. In the Newton's second law, there are many problems are going to be there. Something like a body having certain mass and having certain acceleration, then what is the force of the body? So those are the things we'll discuss in the Newton's second law. Then Newton's third law, for every action there is an equal and opposite reaction. Action and reaction, so they are acts in opposite direction, they are acts on different bodies. That things are explained. It is involves the fundamental symmetries. So those are all the things which comes under the Newton's third law. So the Newton's second law, when you are talking with mass, the gravitational force exerted by the mass is called weight. The gravitational force exerted by the mass is called weight, and the standard problems like friction and all these things comes under the Newton's second law only. The force of gravity, so all those comes under Newton's second law. This is just a simple mind map of all. So Newton's laws, Newton's first law, Newton's second law, Newton's third law, how they are classified. See, then Newton's second law, we are talking main important in Newton's second law only. The Newton's second law which relates all these things, the force equal to mass into acceleration, the net force equal to mass into acceleration, and the visualization examples like bodies having certain mass and due to the application of the force, so body has acceleration. So that those things and the limitations, it is extremely useful, but there is some limitations are also used there. Standard problems are there, and friction related problems are also comes under the F is equal to MA. And another way, it is also applicable for extended objects, the extended objects and cause of motion. So all these things which are again relates with Newton's first law, Newton's third law, and the center of mass, two body problems, etc. All these are related with each other. This is another mind map of Newton's second law. See, coming to the Newton's second law states that what? Acceleration is directly proportional to force and inversely proportional to mass. Means, see, inversely proportional to mass. Mass is bigger than smaller acceleration. If you observe here very clearly, the illustration here, Newton's second law illustration, what it says? In the Newton's second law illustration, it is clearly explained that if the body has greater mass and a lesser acceleration, if the body has lesser mass, greater acceleration, this is just explains acceleration is inversely proportional to mass. Acceleration is inversely proportional to mass. The same force exerted on larger mass produces correspondingly smaller acceleration. See, this statement you can understand. See, the same force, here the statement what it is there, just the same force extended on larger mass produces correspondingly smaller acceleration. You can understand here acceleration is big but mass is small. See, here mass is big, acceleration is small, which enables the comparison between these things. One is, see, other mass and acceleration are inversely proportional with each other. This what explains Newton's second law. See, the derivation of Newton's second law, simple derivation, acceleration is directly, so acceleration is, you can take it as, see, acceleration is directly proportional to force and acceleration is inversely proportional to mass. So acceleration is directly proportional to force and acceleration is inversely proportional to mass. So when you combine these two equations, acceleration is directly proportional to force upon mass. So A equal to K into force upon mass. So where K value is 1, then F equal to MA. F equal to MA. This is one type of derivation. There is another way of deriving Newton's second law. There are two different ways you can derive the Newton's laws. See, the another way you can derive like this. The rate of change of momentum. See, rate of change of momentum. Rate of change of momentum. The rate of change of momentum is directly proportional to force. This is another way. What is mean by rate of change of momentum? Rate of change of momentum is nothing but the final momentum minus initial momentum. Final momentum minus initial momentum. See, something like final velocity. Yeah. See here, the final momentum minus initial momentum is directly proportional to force. Momentum is denoted by P. So Pf minus Pi. So momentum is nothing but mass into velocity. So m into Vf minus m into Vi. So that equal to, that is directly proportional to force. So change of momentum, this is change of momentum. Rate of change of momentum means divided by time. So mvf minus mvi upon time is directly proportional to force. So mass into change of velocity, vi minus vf minus vi divided by t equal to kf. So here vi is the initial velocity, vf is the final velocity. The final velocity minus initial velocity upon time is called change of velocity, the rate of change of velocity, that is called acceleration. Then that is nothing but force equal to mass into acceleration. Force equal to mass into acceleration. In this way you can derive the Newton's laws. So Newton's second law illustration, which explains clearly, if larger mass, smaller acceleration, and larger acceleration, there could be a smaller mass. If the same force acts on the objects, the same force acts on the different objects, it produces in this manner. See, coming to the next, see, we are discussing connecting bodies. See, what is mean by connecting bodies? In the mechanics, there is a very important, so this concept like contest. So connecting bodies are typically refers to the physical linkage between the connection of two different objects or two or more different objects within a mechanical system, or the components, so something like masses and strings, etc. These are all connected. So that is called connecting bodies, are nothing but typically refers to the linkage between the physical linkage between the components of the system, the mechanical system, that we are calling it as a connecting bodies. When the bodies are connected in the mechanical system, the force of contact plays very important role. See, if the two bodies are there, let us take the two bodies, if they contact each other, see, something like this is one object and there is another object which is contact. So m1 and m2, there are two different masses. There is a force of contact between the two objects. So that force of contact, see, let us say the force of m1 acts on m2, the force of m2 acts on f1. So this is called contact force. This contact force is very important in the connecting bodies. The force of contact is which refers the force exerted by one body on another. The force exerted by one body on another at a point where they are contact. That is called force of contact. So at a particular point, the force of one body acts on another body. This force affects the stability and the behavior and overall performance of the system. The force of contacts, it explains what the body, it has got the stability, or it has got the what type of behavior and overall the motion of the objects is described by that. So that's why it is a force of contact is very, very important in the connecting bodies. See, coming to the next one, in the connecting bodies there are some important points you have to remember. So the first point is the transfer of the forces. When the bodies are connected, the transfer of the forces, the reaction of the forces, friction, etc. These are all some of the important points. See, the transfer of the forces are nothing but when the bodies are connected, so there is some force which is going to be, see, for example, if a body is connected like this, if a body is connected with help of a rope, so when it is connected with help of a rope, so let us take m1 and there is a m2. You are applying a force on the m1. So due to the application of the force on m1, there is certain, this is the contact force. See, here capital F is the force, here contact force. The contact force plays important role. So that contact force between the bodies, when the bodies are connected, so with a rigid joint like rope or fastener, etc., these forces are going to be, there is some transfer of forces will take place. Here let us assume that here 10 newtons is applied. So the mass of a body is 5 kgs, here mass of a body is 2 kg, but the force of contact will be different. So it means it transfers the force. How can you say it is different? See, you can find out actually. So the force 10 newtons is acting here. 10 minus the force of contact is equal to 5 into acceleration. You can write one equation. if you write the free body diagram and resolve the forces. And the next case, Fc, the contact force is equal to mass into acceleration, that 2 into A. This is second equation. So when you combine, in the first case the M1 object, there are two different forces are acting. See, M1 object, if you take, this is the M1 object, the force 10 newtons is acting and a contact force is there, the contact force Fc is acting. So due to these two different forces, so the object has net acceleration. The net acceleration is 5 into A. So mass of a body is 5 kgs, acceleration is A. Net force is nothing but 5 into A. So 10 minus Fc is equal to 5 into A. Similarly, M2 object, there is only one force which is acting on M2. That is only contact force. That's why Fc equal to the mass of a body, in the second case 2 into acceleration. When you try to solve these equations, so for example, first equation added to the second equation, Fc get cancelled. So 10 equal to 5a plus 2a. Then acceleration equal to 10 by 7 you are going to get. See, 10 by 7 is the acceleration. So from that you can find out, see, what is the contact force. The contact force here, if you find out, so acceleration is nothing but, so 10 by 7, so it means 5 into 10 by 7, 5 into 10 by 7, so that is 7 7 ja 49 approximately, so 50 it is there. So 10 minus 7 approximately you take, see, 3 newtons. If 10 newtons is acting on M1, so then the contact force is only 3 newtons here. 3 newtons is the contact. So it means that, see, the transfer of forces are taking place here. In the connecting bodies, there is a transfer of force. Here 10 newtons is transferred into the 3 newtons due to the mass. So this type of transfer of force will be there in the case of the connecting bodies. Then reaction of the forces. What is reaction of the forces? In the connecting bodies, the force of contact generates some reactional forces. Just now I explained it. So there is some reactional forces to make the body is in equilibrium. When you draw the free body diagram, so we are taking all sum of the algebraic sum of all forces, so are equal to 0. That condition you are applying and you are solving the problem. That point also you have to remember. Then third one is friction. Since it is a contact force, there is a friction is also sometimes it is going to be acts. That frictional force also should be taken into consideration. So next there is a force of contact and a surface interaction, normal force. All these are the important points you have to remember in the connecting bodies. The force of contact is, just now I told you, force of contact is the force which is there at a point where the bodies are, the point of contact is taking place. So that is called force of contact. And the surface interaction. See, what are the factors of surface interaction, like roughness and other factors, whether these interactions results like friction or adhesion, etc. See, cohesion, adhesion, these are also important properties of matter. See, if the similar molecules of matter is there, that is cohesion, and dissimilar molecules of matter, the force exists between them is adhesion. So friction, when there is a contact between two surfaces, there is a friction will be there. So which results all these the connecting bodies are transmitted forces or other energy in this manner. See, coming to to derive the mathematically finding acceleration like M1, M2, M3 are the three objects, so which are going to be connected by a rope. So this problem, so the masses of M1, M2, M3 are the three bodies are having, there is a tensions like T1, T2, T3. So those things we'll discuss in the next video. So we'll continue. Thank you very much. Thanks for watching.